Yeah, so today we're going to study about the univariate analysis. And so what is actually a univariate analysis? So suppose we have three feature here. The first feature is height, the second feature is the weight, and the third is the output, which shows that whether the person is obese or not. So if we are considering the univariate analysis, so we will consider only one feature. So for now, if we consider the weight feature, like that make more sense. So if we take the weight feature, on the basis of weight feature, we have to consider whether the person is obese, slim, fit, or non-slim. Okay, like three feature only, three output only. So based on that, we will have some variation in the where the y-axis should be 0, because the y-axis will be the height and the x-axis will be the weight. So we will mark all the weight in the x-axis. So x-axis we will start with the 90, 50, and somewhat like that, but we will do that in the Python. So based on that, it will segregate, it will form all the data such that it will be classified into three categories. What are those three categories? All those three categories will be either this will be the obese, this will be the slim, and the third one is the fit. That solves the problem, right? But there is a problem. What is some values are overlapped? Okay, so some values are overlapped. What I mean by that is, so for example, some person is having a weight of 90, and maybe he comes into a slim, and he is having a height also, more height, and comes under the slim category. Okay, that can be possible. So for that matter, we need another feature, so we will consider the height feature. So now we are considering two features. So we will say that this is a bivariate because this is a two variable, or we will say the two feature segment. So how we will discuss that is, if we consider two features, okay, at a time, and based on that we are judging that output, how it will segregate the data, okay, how it will classify the data. So it will form some segment like this, some weight will be like this, some weight will be like this, and it will form something like this. Okay, so based on this, it will form again some analysis, and it will do that this person is slim, fat, and obese. Okay, but again there is some problem with the data, that what if there are two more feature, or let's say three more features, like age is there. Okay, age is there, and let's consider their professional life is there. Okay, so based on those data, but see, we can draw 2D diagrams, we can make 3D diagram. Okay, so if the age is also there, we can make 3D diagrams, that makes sense, we can see it. But what if we consider one more parameter, we consider one more feature? How can we imagine it? 4D diagrams, we in human life we are not able to see it. So how can we do that? For that matter, we have a library, a wonderful library, it's called Seaborn. And in Seaborn there is a function that what it will do is, it will uh, draw the diagram. So for example, age is there, okay, and what is there, height and weight. Okay, then again the professional life. So what we'll do, we'll see that there, whether there is a correlation between them or not. We will see that if age is to age makes a graph, so it will actually make a graph, and it will make a distribution, so that we can see that it will so when the age will increase, automatically the professional life is increasing, like what kind of professional life he is in. If that makes sense, then definitely it's a correlation, and we can see a correlation factor also. So for that, in Python there is a term, there is a function called core, and we need to pass the value, we need to pass a parameter in that. So based on that we can find a correlation between all of them. Yeah, that's all for the univariate and bivariate. In multivariate, we have different. So this is actually the multivariate, since we already done the bivariate part. So when we have more than three functions, more than three features, then we are using the multivariate function. Multivariate function, we have a Seaborn library, which is using a different uh, graph to identify the relation between all the other parameters, all the other features. Thank you so much.